What's up? This is Told the Scientist from the Nerd Podcast. The Nerd Podcast is an educational podcast discussing neuroscience topics. The purpose of this podcast is to learn different neuroscience topics and how neuroscience relates to your life or everyday living. Whether you're an expert in neuroscience or a beginner getting into the brain, have the nerve to stick around. What's going on, people? This is Tone, the Scientist from the Nerd Podcast, here with another episode. First off, I want to thank you for this new opportunity to discuss neuroscience topics and how it connects to our lives. Secondly, I want to say it's good to be back in the studio where the magic happens. Shout out to Risky Studios in East Lansing. And thirdly, I got this neuroscience joke for you. I'm a bit of a comedian. So, why was the neuron sent to the principal office? Because it couldn't stop controlling its impulse. Get it? Because, like the neuron, the impulse. If you don't get the joke, that's okay. But hopefully by the end of this episode, you will. And lastly, and certainly not least, I got this friend of mine that I want to introduce. It's a brainiac and one of the inspirations of this podcast and one of the reasons why I do neuroscience. Ray, the brain, what's good with you?
What's good, Tom?
I'm good, man. Being present in a moment. How you doing, Ray?
I'm electrified.
Alrighty then. Now today's topic is it's about the basic unit of the nervous system. And if you recall in last episode, the basic unit of the nervous system is cells. There are several types of cells that impact how the nervous system functions. Now again, today's lessons are rather simple and it's applicable if you have an ear for listening and a heart for understanding. The first lesson, there are two types of cells in the nervous system. The neurons and the neuroglia. It's pretty simple, right? Two types of nerve cells in the nervous system are, neurons and glia. Neurons are the cells in the nervous system that receive and send signals throughout the body. So it can be from neurons to neurons, you get those signals, they travel to the brain, or they travel to the spinal cord, and then they send the signal to the brain. Neurons can be classified into sensory neurons, motor neurons, and interneurons. The sensory neurons, they deal with the different sensations like touch, taste, hear, sight, smell, proprioception, and the vestibular sense. Now, those last two, proprioception is your sense of awareness and your body's position or movement in your environment, whereas the vestibular sense, it pretty much deals with balance. And I would tell you that the vestibular sense is really controlled by your inner ear. You also have motor neurons, and those neurons, they connect to muscles to help you, move your muscles, flex your muscles, move your body. And then you also have interneurons. These type of neurons are the most abundant in the body, and they relay signals and control which signals is to continue or not. Now, these three type of neurons, you can classify these neurons based on structure, which we'll probably get in later in this episode. And you can also classify these neurons based on the type of neurotransmitters they release. But that's a different discussion for a different day. The second type of cells in the nervous system are neuroglia, and I will refer to them as glia for the remainder of the episode. Glia cells support neurons in a variety of ways. One, they destroy those different pathogens that try to attack and damage neurons. They also remove dead neurons or neurons that are not functioning properly. They also insulate neurons, provide nutrients to neurons, and surround neurons just to hold them in place so that they function properly. Now, there are 6 different types of glia, and they differ by function and location. The first type of glia cells that I'll talk about are astrocytes. And astrocytes, what they do is provide nutrients and protect the neurons from pathogens. The second type of glia cells are oligodendrocytes, and these cells support neurons by coating them with this particular substance called myelin, and it's a fatty substance that covers part of the neuron that helps insulate the neuron to help, signal transmission. So in a sense, this fatty substance is around the neuron such that the signal travels a lot faster compared to if it didn't have any of this myelin. The third type of glia cells are microglia. And what they pretty much do is they prune neuron synapses and destroy neurons that are not functioning properly. So at the bottom, where we'll talk more about the neuroanatomy of the neuron, at the axon terminal, what a microglia does is it prunes that area such that the signal is either going to transmit quicker or is going to remove the synapse such that the neurons are not able to communicate with each other. The fourth type of glia cells are epithelial cells, and these glia cells, they're pretty much in the central nervous system, and they help line cavities that are present in the brain and the spinal cord. So the four types that I mentioned, which are astrocytes, oligodendrocytes, and epithelial cells, are found solely in the central nervous system. However, microglia can be found both in the central nervous system and the peripheral nervous system. And then you have the last two type of glia cells that are only found in the peripheral nervous system. The next type of glia cells are satellite cells. And these cells, they protect neurons and provide nutrients to the nerves of the body. So anything that's, in your limbs, your legs, your guts, your chest, those satellite cells are present there. Then you have the last type of cells in the peripheral nervous system, which are Schwann cells. And they pretty much just add myelin to the peripheral nerves in the peripheral nervous system. Now pause. Remember how oligodendrocytes, they also add myelin, but it's in the central nervous system? So the question is, what makes Schwann cells so different? I would tell you is how they add this fatty substance myelin to the neurons. What Schwann cells do is they wrap themselves around the neuron and myelinates the neuron, while the oligodendrocytes, they just secrete myelin, so it's like they're throwing myelin at the neuron. To, I guess, give you a more of a visual, think of it like this. You're asking for help to move a piano. You have two people that are willing to help you. A person that gives you all the information you need to move the piano and expects you to go move that piano itself. Or you have that other person that's going to, in a sense, mimic every body movement that you do. So as you start to pick up the piano, he's going to pick up the piano. As you, move the piano up the stairs or get it to a different location, that person is doing the same thing. So I would tell you that first person who gives you the instruction, that's the oligodendrocytes. Whereas the second person who's more hands-on and imitating what exactly you're doing, that's the Schwann cell that is giving you the information or the myelin that you need to be able to function properly. So remember, two types of nerve cells in the nervous system, which are neurons and glia, and each of these cells can be classified based on function, and these cells play an important role in the nervous system. The second lesson is the anatomy of the neuron is broken down into different parts like a planned out party. Now, neuron anatomy, it includes the dendrites, the soma, the nucleus, the axon terminal, the nodes around VA.
Yo, Tone.
What's up, Ray Ray?
Break it down. Many of these people don't know what these words mean.
I got you, Ray Ray. Let's put this in the context of a big planned out party. The first thing that probably happens is the idea of having a party. So, whether it's a wedding party, anniversary party, or birthday party, you have to have the idea to have a party. And then you begin to think about or plan the different parts of the party. The first thing you might focus on if you were excited about the party is creating special invitations to send out to people about said party. So you invite your best friends, your colleagues, your homie, your secret crushes, your admirers, etc. Then you also have to think about, having a location, because, you got to have a location for the party. You just can't have the party in your head because that doesn't seem like a whole lot of fun. So you look for, different places, spacious places like a warehouse or a club or just a big old house. You also may want to include security because, you never know who might show up to the party. Party could be jumping, then you have the wrong crowd there, and then the party gets shut down. Of course, you need to have a DJ because if if it is a party, you gotta have music. And if you really care about the people, you may have food or drinks there. That's if you really care about the people. Now the day is here and you have this, really well planned out party. Now let's look at the different parts of the neuron and relate it to this party. When you created the invitations to send out to the people, you can think of that as the axon terminal. So the axon terminal is the part of the neuron that transmits signals to other neurons or tissues. So now that you got the people that showed up because you sent them the invitation, the people, they look good, they feeling good, and ready to have a good time. But before they get in, they need to go through security. So security, you can think of that as your dendrites. And so the dendrites are the part of the neuron that receives signals from other neurons. So the security doesn't just let, anybody in. They got to make sure that they look decent. I guess they got to fit the norm of what's cool, I guess. I mean, but that's a different discussion for a different day. But you can't allow just people, not anybody, to come to the party. So the people go through security, and so they don't see anything wrong with them. And now you allow people in the party, and now the people are going into this, this spacious place where the party is. Now the people are going into this room where the DJ is and trying to figure out what to do because, one, they hear music, but then two, they also smell food and, see a bar or a place where the food and drinks are at. In the context of neuron anatomy, this is the soma. And the soma is just like this big old place within the cell that biological processes happen, such as like the production of proteins and neurotransmitters. And so while the people are in, this the soma of the party, they're now trying to decide whether if they're going to go to the dance floor or if they're going to socialize or if they're going to get food because, they probably could be hungry. So now, the people are becoming more situated, getting situated, having a good time. So now it's time for the DJ to act accordingly. Now, the DJ seeing a lot of people, coming into the room, they coming into to this environment, so they got to begin to play music. They play some of the hottest music out, feel good music or music that just gets you dancing. Now, I would tell you that the DJ is the nucleus of the party. And so the nucleus within a neuron is the command center that dictates whether a neuron grows or maintains. Now, the reason why the DJ is the nucleus of the party is because good music can either draw people in, hold them steady, or it could cause people to leave if they're playing the music that isn't so, not getting the crowd jumping. Now, we got to focus on the main, meat of the party, which are the people. So you have all different types of people at a party. Good people, cool people, you just have different types of people. And some people at this party may be enjoying themselves so much that they decide to record other people to, just capture this moment in history. Then you also have just different people, whether it be party promoters or people capturing things at this event. So when they plan the next event, they can really hype up how the next event will be because they have footage from the last event. And you can think of all of those processes and things as the axon of the party. And so in the context of a neuron in the nervous system, the axon is a part of the neuron that sends the signal to the axon terminal. And boom, you talk about full circle. You have the dendrites, the soma, the nucleus, the axon, and then the axon terminal. Those are the parts of the neuron.
Well, what about the nose of Ranvier, Toll?
That's a great question, Ray Ray. I couldn't think of how the nose of Ranvier fit into this party metaphor. Crickets. Well, remember how I said those in the beginning? I talked about how those glia cells they make myelin. Well, myelin wraps itself around the axon of the neuron, and the spaces between the myelin sheets, because there's like different sets of myelin on the part of the axon, and those spaces between those myelin sheets, that is considered the nodes of Ranvier. And what these nodes pretty much do is they just help the signal, or they help transmit the signal faster across the axon, such that the signal travels to the next cell. So remember, the parts of a neuron include the axon terminal, the dendrites, the soma, the nucleus, the axon, and nodes around VA. Now, the third and final lesson is your life is like a neuron.
What do you mean by that, Toad?
Well, you remember that joke from earlier? I will repeat it, but a friend of mine recommended that I don't. So, neurons are one type of cell in the nervous system, and they communicate with each other through signals. And as a neuroscientist who studies the nervous system, I continually to begin to think that my life is like a neuron. Do you understand what I'm saying? Well, let me break it down. Remember those different parts of the neuron, the dendrites, the soma, the nucleus, the axon, nodes around VA, and the axon terminal? Each of these parts corresponds to different aspects of my life. I'll start off with my dendrites. Now remember, the dendrites are the part of the neuron that receives a signal from other neurons. I think of that as my perception. My dendrites is my perception. And in my life, I see a lot of signals and things daily, from verbal communication to nonverbal communication, from TV to YouTube, social media, etc. And recently, I was on my way back to my apartment from campus, and as I was walking back to the bus station to catch the bus, I usually cut through this building such that I don't have to take the long way around the building to get to the bus station. However, as I was trying to cut through the building, the door was locked. So I turned around and proceeded to take the long route. I saw this lady. She got out of somebody's car and in front of the door where I was at, and she proceeds to walk in the same direction that I'm headed. We made eye contact with each other. However, she proceeds to take off running to the door, gets to the door, and shuts the door behind her facing my direction. I knew she didn't feel safe because I was walking behind her, which is why she ran. Now, why do I share this? One, it's just to share the reality is that some black scientists may face in this current environment, even in this day. And two, because it's a teaching moment of neuroscience. The nonverbal cues that this lady displays signal my perception, my dendrites, and now that the dendrites receive the signal, I have to respond to the situation. So, I just smiled, and I continued on the long path to the bus station. Now, I would tell you I ended up missing the bus because I took the long route, so I had to walk to the closest bus stop that would get me home, which was on the other side of campus. And as I walked, I began to think about my day and appreciate all the things that happened, from the small interactions even to a wacky TikTok video I made.
She ran away from you to get to safety?
Yeah, man. That's a doggone shame. I know. I'm a good guy. She was just, I don't know what was going on her head. She was different. Now, the soma is where all the biological or biochemical processes happen to maintain the neuron, and the nucleus is the command center of the cell. Now, I would tell you, as I do my dissertation research, which focuses on how does gut microbiome impacts maternal behavior in rodents, as I do research activities, I listen to music. I listen to music because it helps me focus. Music allows me to cancel the outside noise that I just hear on a daily basis. And the third reason, it gives me a reason to dance. I've never been much of a dancer, but I would tell you there's like a pure joy when I get to just bust a move. It's crazy. And I share this in relation to the soma and the nucleus because my body is the soma, and then my nucleus is the brain. The soma is where all biological things happen that keep me alive, and my brain influences how I respond to life and, how I move, what music I listen to. Now we're moving to the axon, and remember the axon sends the electrical signal to the axon terminal, and the nodes around me is the space between the myelin on the axon. And I guess I just think of this whole entire axon situation is just like my logical response to different situations. If I'm in the middle of the street and I see a car coming at 65 miles per hour, I stand in the middle of the street and I stop it with my two hands because I'm Superman. But in reality, I actually move out the way. But before I move out the way, I need to think about moving out the way. Now, this is, a very shallow example, but it just gives you something to think about if you choose to. Now, remember, the axon terminal is a function which communicates with other cells. And I think of my axon terminal as my communication with other people, whether that be verbal or nonverbal communication. If people are receptive of my communication towards them, we'll continue to interact with each other, and, signals will be sent to each other such that we can continue and foster communications and, relationship. However, if people are not receptive of my communication, or if they're not receptive of, the things that I'm, putting out in the environment, then the signal stops, and then that also leads to the interaction also stopping. What about the glia cells, Toad? How do they fit in the scope of things? What's the main thing you want people to get out of this? Well, I would tell you your glia cells, or the glia cells, are those outside forces in life that shape your experience. An example of this could be, you're in a relationship with somebody, but then the relationship ended for reasons. That process you go through to make until your brain makes sense of why, the relationship ended or why you stopped doing something. Thus, your glia cells either trying to protect you, shape you, cover you, or provide you insights such that you function to the best of your abilities to signal and communicate to other people. Some will call that angels and demons, when those type of situations, occur. But for now, I'll just call them glia. So remember, the three main lessons. The first lesson is there are two types of cells in the nervous system, neurons and glia cells. The second lesson is the anatomy of a neuron includes the dendrites, soma, nucleus, axon, nodes around VA, and the axon terminal. And then thirdly, your perception is influenced by the signals you receive daily. Your perception influences how your body responds to different situations and how you communicate. Some situations can cause you to react, whereas other times it's necessary to be silent. And remember, there are glia out there that are shaping you to become your best you. This is Toad the Scientist and Ray the Brain. Until the next lesson. Peace. Thank you for listening. To stay up to date with us for the next episode, next event, or other neuroscience topics, you can follow us on Instagram at the VA Nerd Podcast. No spaces.